Okay, pre-calc kids, looking at this level 2, which is the lowest level from these leveled reviews, if you will. This one shouldn't be hard. If you take a step back and look at it, this first points that they give you right here, it tells you everything you need to know. Remember, this is your x-axis right here, and this is your y-axis, okay? It tells you Jane starts the stopwatch when Tarzan is at one end of the swing. Y is -18. And she starts her stopwatch, so x is 0 and y is -18. So remember, when x and y intersect right here, that is 0, 0. So that's where your x is 0. So you just need to plot -18. Then the next point, and that would be your minimum. Jane finds that when x is 4, so scale out to 4 on your x-axis, Tarzan is at the other end of his swing, where y is 18. So you go over to 4 on your x-axis and up to 18 on your y-axis. So that's your max. So you have a min and a max. But remember, when you're graphing cosine equations, you need either 2 minimums or 2 maximums. But remember, cosine equations are symmetric. That means you can cut them in half. So right now you have half of the equation or half of the graph. So you have half of the period. Draw in the rest of it. You'll have your period. Then you can find your frequency. You should know what your midline is. It should be easy to find your amplitude. You should be able to tell if it opens up or down the correct way or inverted. Then you should be able to find your amplitude, if I didn't say that already, and if it has a shift or not. So this one should be easy for you. If it's not, you're not doing your work. So let's look and see what we have here. You should be able to do B because it says write an equation. Where is Tarzan after 6.3 seconds of swinging? You should be able to do C because once you have your equation, you just plug in 6.3 into the equation and find the output. And then part D, you would need to have a little bit more information from me, basically how to use that graphing calculator, how to plug the equation into the graphing calculator and look at the graph online. So we're just going to cross out part D right now and move on to our next equation, or next problem, level 3. So level 3, that would be our buoy problem. It says a signal buoy in the Chesapeake Bay bobs up and down. During a small squall, the height of the buoy varies sinusoidally, which means it can be a sine and cosine, with a maximum height of 9 feet. There you go. It tells you the maximum height, gives you what you need there, and a minimum height of 1 foot. Easy enough. And there are 5 seconds between each set of maximum heights. So imagine if this is a max and this is a max. Make these a little bit bigger. There's 5 seconds between there. That should tell you something. That 5 seconds means something between your 2 maximums. It starts with a P, by the way. The buoy reaches its first maximum 2 seconds after you start your stopwatch. Well, we've had a number of problems that say 2 seconds after you start your stopwatch, you're at your maximum height. 4 seconds after you start your stopwatch, you're at your maximum height. And I think that might have been on worksheet 2 or worksheet 1. I can't remember. But this one you should be able to do as well. So just draw your graph. Remind yourself that this point is 0, 0. And then after 2 seconds, you're at your maximum height, which you know. And then it says 5 seconds between the two maximums. So you know 5 seconds later, you have your next maximum. And then you have to figure out where your minimum goes. But remember, everything is about halves. All right? I think you should be able to do that one without any trouble at all. Again, I don't know. I really think you just need to try, guys. So let's see what we have here for questions. What is the height of the buoy after 3.5 seconds? Well, once you have your equation, you just plug that into your equation and you will be fine. What was the height of the buoy when you started your stopwatch? That one you will need to, probably you will need to have your, well, that one actually you don't, because you can just plug in 0 because your stopwatch is at 0 when you start. So you would plug in 0 for your time or for your X. So you can do that one. And then when will the buoy reach a height of 6 feet for the second time? We would need to use our graphing calculator for that. So again, I haven't shown you how to put this into your calculator to look at the graph on there. So we're going to cross out D. All right, let's go on to the next one, level 4. Level 4 is our Ferris wheel problem, which we have done. We did a Ferris wheel problem. I think our very first problem was a Ferris wheel problem, or one that was like it. Actually, our Ferris wheel problem was our second problem. Our first problem was a water wheel. They're done the same way. So if you look at the picture of the Ferris wheel problem that we did, it looks something like this. We did a circle, which was drawn for you. Remember, circles have centers, and therefore we have our radii. And this one says, a Ferris wheel rotates counterclockwise at a uniform speed of 2.5 revolutions per minute. Now, we want to know what 1 revolution is. But it says it has a radius of 20 meters, so 20. And its center is 24 meters above the ground. So 24 meters above the ground. So let's say this is the ground. So that means this piece right here is 4 meters. After the ride starts, your seat takes 4 seconds to reach its lowest point on the wheel. So this time, it takes 4 seconds to reach the lowest point. So before we were talking about it takes so many seconds to reach the highest point. So let's look at our picture here. First of all, you'll want to know what your maximums are and your minimums. So if it takes 4 seconds to get to the lowest point on the Ferris wheel, you would have to figure out where you'd start on this x-axis and what the lowest point on the wheel is. And then you'd also want to know what the maximum height is on this Ferris wheel as well. So I'm going to draw this in as well. Remember, this is also 20. So we have 20, we have 20, and then we have 4. I don't want to give too much away here. But what I will help you with is I will help you with the period. It says 2.5 revolutions per minute. But then it goes down to say your seat takes 4 seconds to reach the lowest point on the wheel. So our x-axis is going to be in seconds, and this talks about in minutes. So I'm going to change that. I'm going to say 2.5 revolutions in 60 seconds. Well, I want to know 1 revolution in what? So I'm going to take 60 and I'm going to divide it by 2.5. Well, that would mean there's 1 revolution or 1 cycle every 24 seconds. So I'm going to have 1 cosine graph every 24 seconds. All right, let's see what you can do with this one. Let's move on and see what problems you can do. A, you should be able to do. I think you should be able to do. C, you can't do. You'll need to look at the graph. Oops, didn't want to do that. Don't know how to erase. D, you can't do either. So how about with this one, how about we just write our equation and do part A? Now, I want you to work on these on Monday, and then on Tuesday, how about Monday and Tuesday, you work on all of the problems we've had so far, and then on Wednesday, I will post all of the answer keys, basically these last 3, and then we'll go from there, figure out what to do on the rest of the week. Hopefully I'll be back by then. I'm not real sure though. So again, if you need anything from me, make sure you message me, and please check Schoology updates. I will just try and update you on Schoology as far as what's going on. All right, guys, have a good week.